The word of the day is
conflate.
that's right, conflate. To fail to properly distinguish or keep separate things, or to mistakenly treat them as equivalent. By extension, to deliberately draw a false equivalence or association, typically in a tacit or implied manner is propaganda and or intentional distortion or misrepresentation of the subject matter. That's a lot of pretty big words for a pilot. That's why I had to look it up. And I no sooner turn on the morning news than we see this clip of a Boeing 747 with an engine problem safely returning to Miami's International Airport following the failure of the number 2 engine, and this story is immediately conflated with the Boeing 737 door problem, even though this is an engine problem that just happens to be mounted on a Boeing 747-8. Let's check it out. Here on the Aviation Safety Network, Thursday, 18 January, a Boeing 747-8. This is a 2011 model Boeing 747, so one of the late model freighters. November 859 Gulf Tango with the GEnx 2 Bravo 67 engine. This is the new generation of high-efficiency engines put out by General Electric. More on that in a minute. 5 occupants, 0 fatalities. Atlas Air Flight Giant 95, a Boeing 747-8, suffered an engine number 2 fire. Number 2 engine, that's the second one from the left, is looking from behind the aircraft. The GEnx 2B76 during initial climb after takeoff from runway 09 at Miami International Airport. The flight radioed Miami departure, declared the emergency, stated they had an engine fire, and they returned back to Miami just 14 minutes after taking off. Post-flight inspection has revealed a softball-sized hole above the number 2 engine. And if we look at the Flight Radar 24 data, it looks like the crew did a perfect job getting radar vectors right back around for the ILS approach, runway 09, landing shortly after takeoff. It looks like right about here at about 1,000 feet, there's a little bit of a jink to the left, possibly the reaction of losing the number 2 engine. Remember, a Boeing 747, 4 engines, losing 1 out of 4 engines, especially one of the inboard engines, is really a non-event. Listening to the ATC recordings from Real ATC, the flight crew immediately declares the emergency. A little bit of chatter back and forth between ATC. They get it sorted out that there's 5 souls on board. They've got 5 hours of fuel or 5 tons of fuel, as this flight was only going from Miami to San Juan, Puerto Rico, and that they did have hazmat on board. They negotiated the vectors back around for runway 09 and selected or elected to go for a 10-mile final. Didn't mess around with dumping fuel or running excessive checklists. They just did an excellent professional job, both ATC and the aircrew of Atlas Air Giant 95, getting this right back on the ground following this engine fire. They did mention that the fire occurred on the climb out, and they did mention that it took them about 2 minutes dealing with this engine fire. So it sounds to me like it didn't quite go out right away. And looking at that video, it looks like that may very well have been the case. Looking at this video clip captured from the ground, this appears to be the initial engine failure on departure, and it looks to me like what we're looking at is turbine blades leaving the rear of the engine. Once a turbine blade has a failure, it'll begin a cascading effect of taking out more and more turbine blades. It'll create this series of sparks leaving the aircraft. I don't hear a series of bangs like compressor stalls, but it just looks to me like turbine blades leaving the aircraft. That could have been initiated by initially compressor blades failing and then going through the turbine section and losing the blades, but the crew did not say anything about a bird strike or anything like that. They just said they had an engine fire. So I'm suspecting turbine blades. Remember, when you shut down one of these engines, the jet engine will continue to windmill even after the engine's been shut down. So it may continue to shed a few parts. This was the Boeing 777 out of Colorado coming back into Denver. This was a rather extraordinary case where they lost the cowling and everything. But the engines will continue to windmill after they've been shut down. This is the GEnx series of engines that's used both on the Boeing 787 Dreamliner and the late model Boeing 747-8 freighter aircraft. The interesting thing is on the Boeing 787, there's no bleed air system. It's a more of an electrically operated aircraft. So only on the Dash 2 models on the 747 freighters does this particular engine use a bleed air system. Like most modern jet engines, it's got a high pressure section and a low pressure section separated by two separate shafts. Here, the high pressure turbine section located here drives the high pressure, man, that's hard to say. Here, the high pressure turbine section drives the high pressure compressor section here, and the low pressure turbine section located back here drives the low pressure compressor section up here and the large high bypass turbofan. Here in this simplified drawing in purple is shown the high pressure shaft and turbine section and the compressor section, and in green is shown the lower pressure. Here's the low pressure turbine section and the low pressure compressor and fan section. So two separate shafts operating two different sections of the engine. And of course right here is the combustion section where the suck, squeeze, bang, and blow. Here's the suck, squeeze, bang, and blow portion of the Brayton cycle goes on. And the reason I'm getting into all of this is because there is an older airworthiness directive on these engines regarding this shaft, the green shaft, the low pressure shaft. When these engines first came out, there was a failure of this shaft right about here forward of the low pressure turbine section. So I'm very interested to find out what was the failure mode of this engine that caused that softball size hole in the top of the engine. One of the things I think the folks at General Electric are concerned about was this a recurrence of this failure of the shaft itself? If this shaft fails, this low pressure turbine section displaces a little bit back to the rear of the aircraft. It doesn't leave the aircraft altogether. It just moves slightly enough to start banging these low pressure turbine blades into the nozzles and just creating all kinds of havoc inside the engine that might very well look a lot like what we saw in the video. The same thing could take place if we just lost one of these blades somewhere along the way and those blades started cascading through the engine and dislodging additional blades. Here's the airworthiness directive that applies to these engines. It's AD 2012-19-08, which came out back in September of 2012. And it affects the entire series of engines, including the Dash 2 Bravos that are put on the 777 freighters. And this AD requires initial and repetitive ultrasonic inspections of certain part numbers of the fan mid shafts, those fans that we showed you in green, for cracks. This AD was prompted by a report of a fan mid shaft failure and a report of a crack found in another fan mid shaft. Now, according to this AD, it says you got to do ultrasonic inspections on these shafts repetitively every 90 days. For those of you that are out there operating in the field, can you tell us, does this airworthiness directive still apply? Are you still having to inspect these shafts every 90 days, or has there been an improvement in the manufacturing of the shaft itself that no longer makes this AD applicable? This AD came out as a result of a mid-shaft failure on a Boeing 787 just doing a taxi engine run test back in 2012. And they found the shaft to fail right about here. And here's some pictures of the broken shaft. And I've not heard of any other additional problems with this since 2012, but I haven't done a real thorough research on that. But there's the failure of the shaft just prior of the low pressure turbine section. And that turbine section shifted back. It sent quite a bit of debris out the back of the engine. The engine failure and subsequent turbine failures were completely contained in the engine. This is going to be real interesting to see on this latest case in Miami. Was this a contained engine failure or an uncontained engine failure? With the size of the sound of the size of that softball size hole, this may be classified as an uncontained engine failure. We got to see where that softball size hole is in the Miami case. because this is the section of Kevlar that's supposed to protect this engine from contained engine failure here over the compressor and fan section. And there's a hardened alloy steel section that protects this low pressure turbine section. In the 2012 787 shaft failure, here's the damage they found in the low pressure turbine case. It did poke some holes in there. And here's some of the damage to the low pressure turbines themselves as they rubbed up against the nozzles once they shifted slightly aft. So once these things start failing, you've got a whole bunch of tiny little blades that can create a large shower of sparks out the back of the aircraft and set off a fire indication up in the cockpit. Or an engine fire can initiate the whole series of events of cascading turbine blade failures. But for the media to conflate this story with the Boeing 737 door story is completely irresponsible. This is an engine problem on a General Electric engine that just happens to be mounted on a late model Boeing 747-8 freighter. Thank you so much for your support of this channel, especially the folks over on Patreon that make this content possible. As we get more information, we'll let you know. See you here.